Hi everyone, welcome back to Agentic SAP YouTube channel. We covered some amazing topics in our last video. We explored ABAP model, we played around with new SAP RPT1 model, and we learned how to optimize our prompts to get better answers via prompt optimizations and all. But today we are moving out of the prompt testing playgrounds and into the actual code. You might ask why? Because end users like HR managers or finance controllers, they are never going to log into SAP Launchpad to do their jobs, and they can't keep on writing prompts and all, right? So they expect AI features to be imported or embedded directly into the custom Fiori apps or backend services which they already use. For example, like if they want to automatically summarize an exception log inside a custom SAP Fiori app, or they want to auto-generate a response to a supplier's email directly inside SAP S/4HANA, or if they want to ask something directly to AI to fetch some info, something like that. Imagine they have an option called Ask AI in the review screen. Like it will be good, right? So today we are going to use SAP CAPM, which stands for SAP Cloud Application Programming Model, to build a custom backend service that talks directly to Generative AI Hub. We are going to write few lines of code in this. So if you are a functional developer or fresher who doesn't have coding knowledge, do not panic. I'm going to explain every command and every line of code in simple English. We are going to build this together step by step. Let's dive in. Okay, before we write the code, I found this architecture diagram from an official SAP code jam repository on GitHub that explains exactly why we are doing this. Okay, if you look at this diagram, the flow is like this: application clients, then we have CAP service, then we have generative AI hub, then we have partner models. Okay, if you look at the far right, application clients, okay, that is our user on their mobile phone or desktop, so they cannot talk directly to an AI model. It's not secure. Okay, so what we do instead, we if you look at the middle box, we are going to build an OData service using SAP CAP. Okay, the CAP service acts as a secure middleware. Our user sends a request to our CAP service. Inside CAP, we use a special tool called SAP Cloud SDK for AI. So this tool securely forwards that request over to the generative AI hub via destination servers. Okay, so this generative AI hub then safely talks to partner models like Azure, OpenAI, or any other LLMs. Okay, so basically, we are building an auditor service to securely expose generative AI capabilities to the outside world. So let's dive in and build it step by step. Okay, now we are inside SAP Business Application Studio, or in short, we call it as BAS. So it is already built into your BTP trial. Think of it as Microsoft VS Code, but running securely in your browser with all SAP tools pre-installed. Okay, so if you don't know how to navigate the screen, you just need to click on BTP trial and launch this Business Application Studio applications under your subscription. Okay, so once you click on that, this screen will appear. So I have this dev space created already. So you guys need to click on this create dev space and choose full stack cloud application and select all the extensions and click on create. Okay, so I'll just show you. So you just need to click this full stack cloud application and select all these extensions, like select these check boxes and click on create dev space. Okay, we have that dev space created already, so I'm just clicking on cancel. So you can create two dev spaces in your trial account. That is the limitation. So now, like once it is created, you will have a start or stop option, so you have to keep it running. So I like once you click on start, it will be in running stage, and this is how it's gonna look. Okay, so now to make this work, we need to write few commands and code inside this space. So we will write all the commands inside terminal. So I'm just opening a new terminal here, and I'm gonna type my first command, that is cds init AI cap project. So I'm just going to call my project name as AACAP project. And if you look at the left screen, there is only one folder now. So as soon as I enter, it's gonna create one new folder. So you can see AACAP project got created, and we have app db sorry folders also created along with other folders. So cds init is a standard command to initiate a project. So basically, CDS stands for Core Data Services. It is a universal foundational modeling language for SAP CAP. So init command is just like initialize. It jumpstarts our project and builds the skeleton folders for us. So if you look at these three folders it created, DB, SRV, and app. DB stands for database. This is where we will create our database tables and define how our data is saved and all. And then SRV, it stands for service. So this is the art of the application. It's where our business logic lives. And then app is like application where our front end Fiori user interface will eventually live. Okay, so if you want to understand more in detail, you can navigate to this cap.cloud.sap. It's like SAP documentation for the CAPM consultants. Okay, so where you can see the CDS database services user interfaces in. So it says core data service caps and modeling language and the very backbone of everything. So we use this command, right? CDS in it. So we are gonna use few other commands like CDS forward, CDS run. So everything uh, is running behind CDS. Yeah? So CDS is like backbone of everything. Okay. So now we have this initial skeleton structure ready. Let's define our folders inside it. Okay, then initially we're going to start with DB, but since I'm not going to talk to uh, DB tables here in my requirement, I'm going to skip this and I'm going to start with service layer. Okay, in service layer, we will be defining service definition file and service implementation file. So what is it? We'll get to know now. So I'm just going to create a new file inside service folder. I'll call it as a service.cds and enter. So service definition file, you have to save it as .cds extension. So in cap.cds file is used to expose OData services. Okay, so this is the design layer. If you check in on this thing, so you have CDS service layer here where uh, we'll see the syntax and all, like how to define this CDS layer and all. Okay, so you can see this service definition file has to be in .cds and service implementation file has to be in .js extension. Okay, so now I'm going to define this service layer. So I'm gonna create one service called AA service. Okay, okay, now we defined our service. So you can see this description like a CAP application mainly consists of the service it provides to clients. Such provided services are commonly declared to service definitions in CDS. So we just defined our service definition file where this file will be given to you know clients so that they can call this service. Okay, so now like we need to define a custom action inside our service definition file. Okay, so what is the syntax to define custom action? You can just come here, like here we have uh, like we can define custom actions using main two keywords, that is actions and functions. Okay, like here also we have unbound actions and functions and bound actions and functions. So let's not go in detail for that, but to what is the syntax to define action is like this: we have to use the action keyword and then the name of the action, input and output thing we need to define. Okay, so basically function is used to read calls only, but action is like CRUD operations and all, like other than read and all. Okay, so that is a difference. And bound and unbound is more of unbound is like you have to define, like you don't have to define an entity and all, like entities will be defined in data models DB layer. So if you want to take entity reference, then we have to go via bound actions. If you don't want to take entity reference, then it's unbound actions and functions. So now I'm going to define a custom action inside my service definition file, that is action. Then I'll give my action name is ask AI. Okay. Then what it should do, it should take the question or prompt from user in string format, and then it should returns string. Okay. So in simpler words, like we just created a service called AI service. Inside it, we have an action called ask AI. It takes a user question, which is a string of text, and it promises to return and answer another string of text. Okay. Now, to write the actual logic, we need our SAP CAPM application to securely talk to SAP AI core, right? So for that, if you want to write code from scratch, we would have to write like 1,000 lines of complex codes to manage API tokens and format and JSON payloads just to connect to the model. Okay, like this security and OData formatting is gonna take too much of time, and we need to write 1,000 lines of complex code. But to solve this, SAP gave us the SAP Cloud SDK for AI. Okay, SDK stands for Software Development Kit. Like think of it as a pre-built toolbox. Okay, it abstracts all the complexity away, and it natively handles the OAuth token generation, automatically formats our requests in JSON format for models like GPT, 4o, or Claude, or any other LLM. Okay, so I'll give you a simple analogy. Okay, like think of it like buying a bookshelf from IKEA. Okay, if you don't have IKEA or any other shops, like you would have to go to forest, chop down a tree, cut the wood, and build the bookshelf yourself, right? But this IKEA gives you pre-cut pieces, screws, and instructions manual, so you can just put it together quickly. Similarly, SDK is like IKEA, which has this pre-built tools inside it, which is gonna do heavy lifting, like it handles all the word token generation automatically, formats our requests for LLMs and all. So that heavy lifting will be done by SAP Cloud SDK for AI. So for that, we have to, like, to make use of that, we have to install that tool inside our project space. So let's install it in the terminal. I'm gonna type npm install at SAP AI SDK/foundation models. And I'll just click on enter here. See, if you look at left side screen, there is no node modules folder here. So as soon as I enter, so it added few packages. Okay. So like we got node modules folder also. Inside this, we have this SAP AI SDK. And if you open this, sorry, yeah, we have foundation models here. If you just open this, we have this Azure Open AI model uh, imported by default. Like when I, as soon as I enter this command, it just imported all the node modules also. If you look at package.json, it the dependencies got added, like it imported all the SAP AI SDK foundation model and all. Okay, so now like it imported everything, like it acts like an universal translator. Now this tool, it natively knows how to talk to LLMs inside our SAP environment. Okay, but now we have the service definition file created, and SAP Cloud SDK tool imported. Now we have to define our service implementation layer. So why we have to define the service implementation layer is because in SAP CAP, we typically, like, define our data models and services in a .cds file. That is the design, but uh, the service implementation is like the custom implementation of the design. Okay, like if you look at this CAPI document. Okay, uh, so now if you look at this screen, like implementing service implementation file, uh, we have to define it the same name as service definition file, but the just extension varies. We have to save it with the .js extension, okay? And you can save it with other names also, but then you have to define that explicitly in service layer or package.json layer, so you can see that info also. Using this at impl field, you can define the path of that the .js file, and you have to define this explicitly, or you have to define this in package.json file, like with this path and this keyword, okay? But like you have three ways here to define, like with the same name or with different name. If it is with different name, then you have to define explicitly in either service definition file or package.json file. So let's define that service implementation file. I'm gonna click on new file and say a service.js. I'm gonna use the same name and save it with .js extension. Okay. So now we have this .js file created. So what does this service implementation file exactly do is like it tells CAP framework, like when an user calls the ask a action, like you execute the custom logic whatever we are going to write inside this file and return the answer, okay? Like that custom logic, when user calls the service and calls this action ask a action, what needs to be done has to be defined in .js service. So this code acts as a bridge between incoming OData request from a user and an external LLM hosted on SAP AI Core. So let's write this code. I will explain it line by line and concept by concept. So to define the service implementation file, what is the syntax? You can see that here. So this is a syntax for that. Const CDS equal to require. We're gonna import the required foundation models, and then we are going to expose our service to CAP framework, and then we are going to extend CDS dot application service to the service which we defined, and then we have init methods and return support dot init methods. Let's see this in detail. So I'm going to define the same uh, using the same syntax. I will type const 0. So this is suggesting to use few models. So I'm going to use our SAP SDK Foundation models which we installed. So like what I did is I simply defined a like this is just acting as an import statement, okay? Const is a JavaScript keyword, like it used to define or declare a variable. Then I have used Azure OpenAI chat client. I have defined this method. It is called as object destructuring, okay? So like now this SAP SDK is a massive toolbox with many tools, okay? Instead of importing the whole toolbox, we are just opening it and pulling out only the specific line designed to chat with Azure OpenAI models, okay? So then we have this require SAP AI SDK Foundation models. This is standard Node.js way to import external libraries. So like this official SDK handles all the complex authentication, routing, and principal propagation required to securely talk to SAP AI core behind the scenes. So this is just us pulling the SAP SDK into our file. We are basically saying, bring me the tool that knows how to talk to like OpenAI and all, right? So now we need to define service class definition. So for that, we're gonna write module dot exports equals to Okay, so if you look at the syntax, the next line is model.export equal to class name of the service which we defined in the CDS file. Okay, this name and this name has to be same, and then extend CDS dot application service. Okay, so what does this line do is like model dot exports exposes our code so the cap primer can find and execute it. Okay, so then we have class A service, which is the service which we defined in dot CDS service file. Okay, so this defines an object-oriented class. Okay, this class AA service, it defines an object-oriented class, uh, and the name AA service must exactly match the name of the service we defined in our .cds file and extends CDS. So I think this should be, yeah. And then extends the CDS dot services inheritance. Okay, we are telling our class to inherit all the standard out of the box behaviors of a standard cap service like handling HTTP requests and OData formatting. Like we are extending the core CDS.service. This means we get all SAP's powerful built-in security and routing features automatically without having to write them ourselves. Okay, so next is like we have to define init method. Okay, so I'm just gonna copy this part, paste it here. Okay, so now when we define this init method, we have to call super.init method again to end the process, but I'm going to override this with async. I will tell you why I'm overwriting in next lines for that. So now it says register your handlers. Okay, so in service implementation file, like here in my code, I'm going to use two main concepts, that is event handlers and async and await promises. Okay, so what is this event handlers and async in it? I'm going to explain later. So before that, I'll just type this event handler thing. So just this dot on. Okay. I'll just write this and explain all this at once. Just give me a moment. Okay. So now what is this async and await? So I have used async and await again in line number 6 and uh, line number 8, right? So this is a concept called promises in a, JavaScript. Okay, so like I'll try to explain with an analogy. Okay, like async and await means JavaScript promise. It's basically acting like a patience protocol. Okay, like this is the most critical part of AI development. Like LLMs are slow, right? Generating tokens takes time. Not just LLMs. Even when you deal with database, and if it's gonna take time, you have to use this async await method. So it's like say for example, if I ask any LLM to like say for example GPT-4 only, like I'll ask some complex question. It might take some seconds or minutes to generate the answer. So node.js here we are the service end time, which is a single thread server. Okay, if my server just stands there staring at the screen waiting for the AI for 5 seconds so and so seconds, the whole server freezes, right? And no other users can use our app. So a promise is exactly what it sounds like. Like we send the prompt to the AI, and then AI says, I don't have the answer yet, but I promise I'll ping you when it is generated. So the code async await is like I put async on the function. Like here, I'll put async on the function on line number 4 and 6, uh, init and request. Okay, uh, to our node.js, like this mission involves talking to an external AI or DB, so it's going to take some time. Then I put await right in front of AI call. Okay, so this tells my server send the user question to AI. It takes the promise ticket and then go help other users. Like pass this specific piece of code right here and like wake it up when the AI finally sends the response. Okay, like it's like it is we are just writing to avoid blocking. Like it's gonna take time, but just focus on other users or something like that. Okay, so now again, this is one concept async. Await, but then again in fourth line we written async init also. Like this is like the initialization phase. Like whenever service starts up, the function runs to get everything ready. uh, like then we have this initialization command. Then I just explained the async await thing. Then we have this dot on. This is our event handler. Okay, what is event handler? That we can see it here. So we have other event handlers also, like this dot before this dot, after this dot, on and all. Okay, so here in our case, this is acting as a event listener. Like we are telling our service whenever a user triggers the ask a action, uh, like it is basically like a menu. Okay, like we are just telling what is there to order. But then when uh, user actually calls the service, it triggers the ask action we defined in our menu. Like then we are telling like execute the code inside this block. Like we have other event handlers also, right? This dot before and after that, that is actually gonna based on when the action needs to be done. So here we have used this dot on because we are only jumping into action when we receive an incoming event as AI. Okay, so this is like actually doing the action during the runtime itself. Okay, this dot before is like before creating something, or like whatever the action they define. Like say for example, get stock or create sales order. Like if they want to do some actions before creating that or after performing the action, then we are going to use this dot before or this dot after. So in this case, we have used this dot on as case. So and as soon as user enters ask AI or user calls ask AI action, we are going to jump onto this and execute this code of block. Then ask AI is the name of the action which we defined in .cds file. Okay, if you look at this action ask AI is the name which we have given. Then we have this async request. Again, async await is like just telling to not block or waiting for the response. And then it's an asynchronous arrow function. Like the request, this request object is important. Like it contains everything about the incoming call, like including headers, user info, and the payload. Like it contains everything. Like it contains the question the user asked also, right? Then we are defining a variable user question to store that request data, right? Like we need some variable. Like this request dot contains data. This contains the JSON payload sent by the user, and dot question is a specific field containing the text prompt. So we are just importing all the requests, including the prompt and JSON payloads inside the user question variable. Okay. So in simple words, I can say like, front end just send an ask a request, then the request object, this request object which we defined on line 6 is a package the user sent from us. Like I'm opening that package, looking inside the payload that is in JSON format and grabbing the text they typed, that is the question. And so like I can hold it in the user question variable. Okay. Then uh, we have this request ready. Now we want to now we want the response, right? So line number 8, so I just defined like constant response equal to await Azure OpenAI chat client dot invoke. So this await again comes here, like this uses await function because calling an AI model takes time, like network latency and processing control. Node.js will pass the execution of this specific block of code until the AI replies, okay, like freeing up the server to handle other users in the meantime. Like now this Azure AI open chat client dot invoke, this calls the method of the tool we called in line number 1. Okay, so then inside that, like we have to tell which is the specific model which we want to call, and LLM requires the request in specific format. So that thing we are going to define here. Model name, I'll keep it GPT-4o. Then we have to define messages. Messages. So we are going to give user role. We have other roles also like system assistant and all. I'll explain this later. Then we have to define content, which is a question. Okay, now then spell mistake. Just correct it. Okay. Since I've used async init, I have to replace it with await support.init. Then just use this syntax error. Where is it? Okay, here. Just click on format. Okay. Now we define that line number 8, right? Constant response, and we are invoking our the method which we defined on line number 1. So then inside that we are defining a model, right? Like GPT-4o specifies exactly which model deployment in SAP AI core we want to use. Then we have defined a messages where we have defined role as user and content as user question. Like this is the standard generative AI prompt structure. Like LLMs expect an array of messages. Role as like you we have defined user role means this text comes from the human. Like other roles include system for instructions or like assistant for past AI replies. Okay, so the content user question which injects the variable which we extracted from the OData request. Like we extracted the request, I mean JSON payload and the prompt text, right? So that's we're gonna inject into the LLM. Okay, so in simpler words, like this is like core engine of our code. Like I use invoke method I specifically dial into GPT-4 model. I package the user question in the exact format the AI expects, like in an array of messages where the role is the human user. Okay, then I use await. I'm telling the server to pass right here and wait for GPT-4 to finish generating its response before moving to the next line, right? Then we have at line number 12, I've written like return response dot get content. Like this sends the data back to the user who made the API call. Like the raw response object written by the SDK that contains a lot of metadata like token, usage, and headers. So that's why I have defined like get content. So this helper method extracts just the text string generated by AI. So we send a clean answer back to the front end. Then this closes the handler. Okay. I think we have to end it here. So then on line number 4, actually the syntax was just init and super init, right? Like where is cds.service? I think it's application service, right? If you see this, this is a syntax, but I have overwritten init with async init, so I have to use await line number 14, then super.init. Like this super.init is very important. Like without this, whatever handlers we have registered, it's not gonna send a response back. So to make this work, we are gonna use the super.init method. So it's since we overrode the default init method on line 4, we must call this at the end, and this ensures that standard cap initializations happen correctly. Okay, right? Then in simpler words, I'm going to say like AI finally responded back. Then SDK returns a massive object with token counts and metadata and all. I don't want to send all that garbage to the UI. I just want the clean AI text. So I use dot get content and return it back to the user. Finally, super dot init is me saying, okay, I've set up my custom AI logic. Now go ahead and finish the standard cap start sequence which I started, right? This makes sense, right? Like now we are just we're not just writing syntax, we are writing the rules for how our server manages time, listens for triggers, and delegates heavy thinking to the LLM. Okay, now our code is perfect. Like there's no syntax error also. Like we didn't put any passwords or API keys in the code, right? Like because SAP handles that securely for us. Like to test this, we first need to log into the Cloud Foundry from our terminal. So I'll just type cf login. Okay, so it automatically fetched my API endpoint. Okay, then which is the underlying engine that runs our apps on SAP BTP. Before we log in, just a minute. Okay, now if you can see, I just typed command cf login and CF stands for Cloud Foundry, like which is the underlying engine that runs our apps on SAP BTP. So it's asking me for email and password, but also it gave API endpoint, which is my trial account API endpoint. So I'm just gonna enter my email, which I registered with this BTP trial account. That is Agentic SAP. Okay, as soon as I hit email name and then it's asking for password. I'm just gonna paste it, enter. Okay. See now it authenticated and it gave me API endpoint, user, org, space, details and all. Like if you see that this is in sync with the trial account which I'm using. Like if you see this org 466B28 and if you look at this URL also, this is all same. Okay, now we have logged into our Cloud Foundry. Now I need to bind my Cloud Foundry account to AA core instance. Okay, for that I'll type CDS bind to AA core instance, and then I'll just hit enter. Okay, then we got this response saying service instance AA core not found, right? So if you look at the response, service instance not found, or like if you try to test it in real time, and you will definitely get 401 or 403 error. So that means like we are not going anywhere wrong, like nothing is wrong in our code, or not, we didn't break anything, like it is just our trial account limitation. So let me show you exactly why this failed. Okay, I had an AI tool generate this diagram to help explain what just happened. Okay, like see, like I have created a 90-day BTP trial account. Consider this is a building A. SAP doesn't provide AI core service inside 90-day trial environment because AI requires massive, expensive computational power and all. SAP just don't put that inside normal trial account. So if you remember, like in our first video, something we try to search AI core instance inside our entitlement, but we didn't get that. Then we follow tutorials to create a second separate trial account for AI Hub. So that acts like a sandbox trial, and which is not inside our SAP BTP global account where our trial account lies, right? This is a separate global account. So now when we ran that CDS bind command, like our cap app searched its own environment, like I mean this building A for the AI core instance, it's not there, like it's there in a completely different global account. So SAP has this military grade security, like it absolutely will not let an app in one global account securely talk to a resource in a different global account without complex trust configurations and all. And even if you try to manually copy paste the passwords from building B into building A, that is from different global account, to force it to work, SAP's security uh, thing won't work, because there is this authentication called as XSUAA, like which stands for extended service user account and authentication. So that will check for the cryptographic signatures and trust configuration. If it doesn't match, and if it doesn't say like it's in same global account, it will give us 401 unauthorized or 403 error. Okay, so since we have this trial account limitations, we got this service in A instance not found. Okay, so we can't easily bypass this without a unified enterprise setup. That means both A core instance and CAP application has to be in the same global account. So since we are on trial accounts, we can't easily bypass that without a unified enterprise setup. But as a consultant, I needed to know how this actually works in a production environment. So for that, there is a blog series by a solution architect Deepa Duraraj. So I've linked this blog in the description and blueprint. Let me walk you through like how to read this. So this is like 6-part series. So uh, part 1 to 4 you can see it in this link. So in part 1 to 4 she covered like how to set up the hub, use Python SDKs, um, then writing prop pipelines and connecting a HANA cloud vector database for RAG and all, like those are great. But part 5 is where the magic happens, like how to bind to a core instance, and the real end-to-end flow she explained, like how it works in production environment, and are we going to use a destination or MTA.yml file, those things and all she covered in this blog. So if we just scroll down, she started with why CAP is the right production layer for SAP AI. So she explains here like it's CAP is not replacement for AI core or generative AI hub. It is the application layer that sits in front of them. Like as we saw in architecture diagram, so AI core handles model access, authentication, and governance. It builds the trust configurations and all. Then which routes the request via destination service, which in turn hub will talk to partner foundation models and then gives the response back to the user, right? So it handles API exposure, service binding, and SAP ecosystem integrations. Both are required for production SAP AI landscapes and all. So then we have this end-to-end architecture also, like uh, the source can be anything like S/4HANA, Fiori integration suite, or mobile user, anything then which is it should call CAP OData REST API, which in turn will send the request to AI Hub. That will talk to HANA Cloud plus vector store, and it will combine the prompt plus vector info to the foundation models. Foundation model is gonna um, retrieve the truth via RAG model and all. Then it sends response back to the user. Okay, so you can see this blog in detail. So now I'll just start from where we left. So we got this error, but a service instance not found error. But then in real production environment, okay, what happens is she explains that we put our SAP CAP app, our SAP HANA Cloud database, and you know. What is it? SAP AI core instance into one single unified BTP sub account, no building A, building B stuff in there. Okay, then in production, we also don't rely entirely on this CDS bind command. Like if you scroll down here, she will use as a BTP destination to connect from integration suite to cap a action. So if you look at this, there is a destination service created with URL authentication, client ID, client secret, and token service URL thing and all. So when an event happens in S4HANA, which triggers iFlow, then which in turn calls cap a action, we will get the response. Then we will route it back to the user. Okay. So this is how it works in production. And then after creating a destination, will have to create a mta.yml file. Okay, this mta.yml file, which contains all the destination details and cloud foundry details. Okay, basically stands for multi-target application. It's like shipping container and an instruction manual for deploying to the cloud. Okay, then we need to enter that command, cf deploy command. So she has given all the commands which we need to type during deployment. So you can see the CF deployment, and then see she use some MTA archive command here. Okay, so that says like when deployed using Cloud Foundry, BTP it securely injects all those destination details directly into a hidden memory vault called VCAP services. Okay, that VCAP services, as soon as it deployed successfully, it's gonna appear in the this project space, and our SAP SDK automatically scans that memory, grabs the token using OAuth, and it routes our prompt to GPT-4o model or whatever LLM you have defined in our code. Then it generates the response and sends it back to the source system. Okay, so here in trial account we have defined this you know, user password and all, but which doesn't happen in real production environment. That's we are gonna connect using destination service, as we saw in the architecture diagram. Now that architecture diagram makes sense, right? Like the request will start from application clients. I mean, it's not necessarily to be start from there. Like it can be like even in S4HANA or integration suite or Fury, anywhere. So that should call cap service, and cap service we have installed a SAP Cloud SDK AI tool, which routes our request via destination service to SAP Generative AI Hub, which in turn talks to foundation models and then gets the response back to the user. So now we covered some great architectural concepts today: global accounts, MTA, Cloud Foundry, CDS, XSUAA, and asynchronous JavaScript and all. We covered also promises, event handlers, action, how to define service, definition, service implementation file and all. So if you are a fresher to CAPM or to these concepts, rewatch this a couple of times. You will understand. So the most important takeaway today is understanding like why our trial account threw that error, and knowing that in real enterprise company everything is securely unified in one account. If you want me to cover CAPM in detail, comment below and I will create a separate series specifically for it. So we can also try to cover community blogs written by architects like Deepa even in more detail. So now since we are constrained by these trial account limitations, we can't easily build full front end for this disconnected backend right now. So we have those so many limitations for that. So in our upcoming videos, we are going to dive into the SAP Joule for Developers workbook. There are 6 parts to it. So we're going to learn how SAP's generative AI assistant Joule can automatically generate full stack applications, automate processes, generate unit tests, and optimize our code for us. Inside SAP build, that is an absolute game changer, and it's something we can get hands-on with immediately. If this deep dive helped clear up those frustrating trial errors for you, please hit that like button, subscribe to the Agentic SAP channel, and I will see you in the next one as usual. Thank you.